The old man Bill. The old man Bill.
Hello, everyone. My name is Nathan. I'm here with Nick with the channel name DK DYKER, and we're going to be talking some cool experiments today. Nick, how's it going?
Hi, Nathan. It's going great. Hi, everybody out there.
Man, there's a lot of good experiments, man, that you've done. I've done quite a bit of the same ones. We did the gravity flyer, both of us.
Yeah.
I did the rod down the center of the Tesla coil, and I'm going to let you say the name to the other one.
Kapanadze.
Yeah, there you go. I can never say that right.
No,
but they're kind of similar in how they work and what they're doing and the process that they're doing. So, and then, by the way, big fan of the Corona motor.
Oh, great.
I tried it, and I made a big fireball is what I did.
Oh, okay.
Yeah, I totally screwed it up.
It can be various things that can happen there. I've also had lots of shocks, and you just have to keep going back and do it again and again and again and again until something actually starts moving.
Yeah.
You know.
I always tell everybody I fry it and find out. And in the middle of that, I zap myself 100 times.
Yeah, and if it's on the same workbench, you put your hand on the workbench, the static charge can also go straight. Yeah, it's not funny, but it is.
It took out my whole table one day. I had static going on in the room, and it filled the room. And I didn't really realize that it was all over the bench and hadn't dissipated yet. And it's like melamine, right? So it's sitting right on that plasticky surface.
Yeah.
And then, boom, as soon as I hit my hand to it, it shot through all my equipment, every board fried.
See, that's one of the bad days, isn't it?
Yeah.
You know, out of every 100 bad days, we finally have one good day where something works. That's the eureka moment. Yeah, they're good, but they're pretty difficult. I started looking at, it was Laser Saber, his channel, and he has a lot of good info on there because after years of looking at various videos about people stating that they've made free energy devices, and if you just copy this design and this design and this design, and the whole idea is it's open systems that we had to look at, not closed systems, because it's all about the external. That's where you're drawing that extra energy in from, whichever design you use. And this Laser Saber, he showed a simple design from a Van de Graaff generator, and across the room, his motor started to turn. And he could hold it in his hand because, of course, he's grounded. And there you go. From that, he put out something. Unfortunately, where I am in Denmark, I can't have a large antenna. It's illegal at a certain height. So that's why I started looking at different ways to power this thing, making a static charge with the scraps that I had available. And then the Walter Cockcroft multiplier. That's what really packed the punch and gave us a lot of shocks.
How many did you put on there? Like 12? Did you put like 12 capacitors on that thing?
Yeah, I think something like that. Yeah.
Oh man,
there's a lot. Yeah, I like the sparks just like you do.
Yeah, because you're going to get like a 4 to 5 inch sparks with 12 capacitors on there with an AC flyback. Yeah.
Yeah. I also, before I went and ordered some of those from, I don't know if it was China, wherever they were from, those capacitors, I looked at a guy. He made the same large spark from saltwater capacitors, his own, but he made I think they were glass jars, and he had 24 of them, salt water, one after the next, and the charge was so big at the end. Mine didn't work like his did, but that was a very small input as well. I think it was like 3.5 volt input from one of those static chargers, and then he increased the voltage through the saltwater capacitors. It's an interesting experiment.
I think that plays I think that plays a bigger role than we think it does. Those capacitors after the charge, when you convert it, because it's got to hold something in there in order to run motors and stuff like that. You got to have an area to store the energy, and then you can release it little by little in the duty cycle. Because if you try to blast it all out at once, you get a real quick run of a motor and it's done.
Yeah. There has to be. I was just thinking, because I looked at your experiment with when you increased the area that you could connect to your Tesla coil by putting crystals in water, and then you were able to go even further. So it has a magnifying effect. Water itself is magnifying. You know, if you, as a diver, we have goggles on, and it's automatically 25% increase in the size of everything underwater. So I'm wondering if you have a water droplet, it can act like a magnifying glass if there's a sun ray going through it, for example. So if there's plasma charge going through it, or whatever we're talking about, it must increase that. I think there's something in those that we're missing as well. That's something that I've been playing with.
So I found that the water and the glass hold together some sort of capacitance in it.
Yeah.
So there's an electrical component here between the two, and the third being the energy in order to amplify a little bit. So the field comes out when you warm the water.
Yeah.
I've got an extra foot out of the field, so it pushes out quite a bit. You know what I mean?
Yeah.
But that extra foot is the biggest thing because of the hot water. And it might have to do with how the crystals form and stuff like that, because you put crystals in there and you put a little piece in there like salt, and then you put the hot water in there, and then it starts to form more crystals, right? So it might be something to do with that process that goes on that excites the crystal in a way to put out a little bit more energy in that environment.
Yeah, that makes sense. That makes sense. Was it just how hot was the water? Just warm water, or?
It was like hot enough to bother your finger when it was in the house, and then I walked out to the garage and put it out there. So above room temperature for sure. Not quite scalding hot. There we are.
I'm back.
It seems like a time thing every 20 minutes or so.
Yeah, it's strange, isn't it? Well, it's a lag. That happens sometimes. So the other thing with the Corona motor, I did different designs because it's difficult to find them. There's not many around. I found a workshop that would send me a very small one to test. I needed the actual dimensions because I needed to take that to pieces and then increase the design for myself and made my own design, because it's very important. On the Corona motor, the outside, the fins, I call them. I don't know what we should call them, but the positive negative that hold the positive negative legs of the charge, they have to be at a specific angle. And if you don't have the specific angle, it doesn't have enough force to push the rotor around. So there's a lot of trial and error with all of that. But I've got some designs. If people want them, I can send them. That's not an issue. You just print them out.
Hey, real quick, is that mic keeps going in and out on you, and I want to make sure if we can fix it real quick. It goes like real good, and then as soon as you start talking for a while, it drops.
Goes out. Yeah, I don't know. This, if you hold on, I can maybe. No, we're recording. I don't have another option right now.
No, don't worry about it. Do what you got to do.
Are you sure?
Yeah, positive.
Hold on a sec. I can see if I can borrow my son's other. That's another option.
Yeah.
Just a sec. Can you hear me now?
Now I can hear you.
Yes. Thanks. Yeah, it's the I may be good at tinkering in the shed, but give me a computer and I can damage it, no problem.
Oh.
Okay.
Yeah, that mic is so much better. Oh.
Yeah. Yeah, it's a lot louder. That's better. Is that better?
Yeah, it's great.
Okay, great. Yeah.
Oh,
okay.
man.
So where were we?
Oh man, hold on. Let's just start over with the whole Corona motor, if you don't mind.
Yeah, no problem. Yeah.
Yeah, that way we can get a nice clean audio on it, and
yeah,
we're good to. You know what?
What?
We should probably just restart.
Yeah.
It's just that audio was so bad. It was diving off hard. Is that okay?
Yeah, of course. Yeah, no problem.
Okay.
Let's keep the power on. There we go.
And it was DK DYKER? DYKER. Okay.
Yeah.
I didn't want to say it wrong.
No, it's like the Danish diver, basically.
Yeah.
Yeah.
Gotcha.
Yeah.
All right, here we go.
Okay.
Hello, everyone. My name is Nathan, otherwise known as Old Man Builds. I have Nick here with me. God, start again. Hello, everyone. My name is Nathan, otherwise known as Old Man Builds. I have Nick here with me. Otherwise, channel name DK DYKER.
Yeah.
Nick, how's it going?
It's going great. Thanks, Nathan. Thanks for having me on.
Yeah, right on, man. Yeah, I wanted to talk to you, man. We have a lot of similar projects. We had the gravity flyer together. You did a Corona motor that was awesome.
Yeah.
Also, and then what's that one? I can't remember the name of it.
Kapanadze.
Kapanadze. It's just like my Tesla coil with the rod down the center. So let's go ahead and talk a little bit about that Corona motor, man. It's always intrigued me. I've always failed to build it. And I think there's just a simple reason why. And I don't think it's a spacer or anything. I'm not giving validity to cutting the corners on a razor blade when you do it and rounding those corners and stuff like that. I always screw up that. Or I don't put the wheel in with enough material on it. Like I'll use aluminum tape or something like that and have plastic underneath. And then I set it on fire because the high voltage. So
yeah,
it'll look like a flaming ball. Yeah.
Great.
I think I saw every color of the rainbow in the fire, by the way.
I'd have liked to have seen that video. That would have been
great. I'll show it to you sometime, man. Maybe when we look at yours, we'll compare and we'll see how bad mine is.
No, it's there's no bad experimenting. It's a process of going forward. Every time we do something like that, we observe something that we can use for the next time, and it'll help us. Just as you said,
that one ended in pure frustration, where it was like as soon as it started fire, I'm like, oh, I spent 3 days on this, right? And I made 3 stacks because I was going to do them like a stack, and then put a gearing at the top so that I can get more energy out of that little bit of thrust that it has. So, yeah, as soon as it started to light, I'm like, oh, well, we're about done here. I spent 3 days. It's not going anywhere. And then it started fire, and I'm like, it's already melted. Then I just cranked up the voltage and watched it melt.
You got to get something out of it, haven't you?
Yeah. Entertain myself.
Do you know? I think, and it brings to mind something. You've made a lifter before?
Yeah.
The top edge on the aluminium. If you made those ones out of that they're normally on the internet, out of the kebab sticks or something. I can't remember what they are. They have the wooden frame, and around that, the aluminium frame goes over.
Mm-hmm.
So the top edge, which is connected, firstly, that will be the first point of intersection from the copper coil, copper wire at the top. It has to be rounded. And then again, we're talking geometry, yeah? It's a teardrop, basically. So you have a sharp edge and then a rounded top. So if you have a sharp edge at the top in the Corona motor on the fins, I call them, I think that can have that's why everybody starts painting it with Corona glue or whatever it's called, to stop that spark, because it can react backwards. It can go backwards, and it just holds the rotor in one position. Then it won't allow it to go anywhere. So it just goes backwards and forwards.
I gotcha. Yeah, mine wouldn't start at all, even if I pushed it a little bit. It wouldn't.
Yeah. They're pretty difficult. Another option might be when you make them, to have something that you can adjust slightly to get the correct angle.
Oh, gotcha.
That might work.
Well, you have a lot of fins on yours. Let me go ahead and pull that up so everybody can see it here.
Yeah.
Let's see.
Yeah, on this, I'm talking about an observation I've made by putting in a spark gap, and that it seems to be drawing something in and allowing even faster rotation, and there seems to be an increase in the RPM. And you can also, if you actually hear it, I can hear it, but I don't know if we can hear it on this. You can hear a tone change, a tone difference. So as it's stepping up to go faster, the frequency changes. It's like a self-adjusting setup.
Okay, well, let's give it a run real quick and see if we can hear it.
Okay, so try and... Did you get any of that, Nathan? Sorry,
yeah, I did.
Yeah,
I was just saying, yeah, let's watch the video a little bit. Is playing it towards the end where it starts up and runs?
Yeah.
Okay, so let's do that, and then we'll see if I can't hear it.
Yeah. Okay. Great. Very small spark over there. It might not last long, this motor, but can you hear that?
Oh yeah.
In RPM, the frequency again. As it steps up again. It adjusts itself. Interesting. But again, rotation more powerful with the spark. There is something being drawn into the spark to give us more force. Something comes to mind. More powerful. Something comes to mind there, Nathan. Sorry to interject.
Go ahead.
It sounded like a bell.
Yes.
When I heard that, and I'm thinking, we talk about Tesla technology with the spark is the transmitter. Once the spark's put into it, it acts like a a wave will be pushed out, like a sonic wave. And I wonder if that's the wave as the spark hits. Does that increase the rotation? Does it give you like an amperage? Yeah, I don't know. A lot of thoughts.
Yeah, I was hearing it trying to tune.
Yeah.
Right there, when I put my finger up, it was starting to try to tune, and then it went right into that sonic frequency right there.
Yeah.
That you heard it. Yeah, it was perfect. It came in clear.
Yeah. I haven't heard it like this before. Probably because I never had the right earphones.
Yeah. So, what I've noticed with the stuff with Tesla, when you get rotating objects, you start to hear those sounds go off, like when I spun the gravity flyer and you got that spark that would go on there. And if you can get the spark to not spark off, but you get the thing right there close to it, and it has the energy pull on the thing, but it doesn't overrun it with the spark.
Yeah.
Then you start to get the singing from the actual blades of it.
Yeah. And I think that's with this, again, that's where it needs to be. It needs to be spaced enough so it can't spark over, even though there was some sparks. That's just because of my gluing and bad designs. But if it's correctly designed, it has to be a way so it doesn't spark over and it just forms the purple corona. Then that's the pressure point that you need. The same, I think, I got an idea when I'm making my this Wardenclyffe example. I believe that's the kind of thing we need to build the pressure wave before the lightning strikes, and that's where the potential is. And that's the same with this, I think.
Yes, it's like a capacitor.
Yeah.
When you take a capacitor and you put the two pieces up far apart, it'll build up enough energy to eventually spark over. Yeah. And it looks like it's doing absolutely nothing in front of you. Yeah. But if you put your hand in the middle, you're going to get a little hello from it.
Yeah, we've done that a few times.
Yeah. Because you're thinking, man, this thing isn't on. What's going on? Is it not working?
I made a film in the dark because I wanted to film the purple corona on each of the fins, because it's fantastic. But I forgot. I was in the dark, and again I put my hand down around the area, and boy, that hurts.
Yeah. Well, I caught an unfortunate one. I was doing stuff with the gravity flyer, and I tried to walk by, and let's just say, you try to make yourself skinny, get through a doorway or something like that. So, yeah, I did that, and I caught one in a bad area. Yeah, that was like a reminder for a week of, it didn't hurt after that, but it was like, you were kind of cautious of going around the whole thing, or even wondering if you wanted to continue with this adventure.
You need to come in total safety equipment next time, don't you? Yeah, I know. Yeah, but I think that's where, if you need some plans, I can send those over so you could print it out. What I've printed out.
Oh, that'd be awesome.
The only difficulty with the laser saber design, which you saw there, is finding the profiles, the fins. Over here, we can't get them. I know they have them in the States, so it's probably easier for you guys to find that specific pear-shaped profile, the aluminium fins.
So is it actually aluminum, or is it aluminum foil?
No, it's aluminum, but I bought I had to buy a plate and then cut some strips off, and then I made a form. So we had I had a piece of wood, two pieces of wood here, and then the foil over the top, and then I made a press so that the sides would roll like this.
So it's open on there and not closed. Does it matter?
No, I think it'd be better if it's closed, because then everything from outside is coming to one point as opposed to 2 points. But maybe it doesn't matter. I've only had it closed. That's why.
Okay, so I built Plasma Channel's ion engine or ion lifter.
Yeah,
It is a thruster. Sorry, thruster.
a thruster. Yeah,
And it calls for the same thing, that pear shape.
yeah,
So
yeah,
I did the same thing. I made a mold on my 3D printer
yeah.
at an ABS,
Yeah.
and then it was a teardrop, and then I pressed it in my vise, and it came out with a perfect teardrop shaped tube.
Excellent. Yeah, I just my problem is with my work pattern. I have almost no time on the evenings, and then all week I have everything that I'm it's coming out in my head, and I'm writing it down, and the weekend comes, and unfortunately we have a house and a garden first, and then everything else is afterwards. So then when I come to do these experiments, I have a very, very short window of time to do it in. So when I'm having to make profiles, they're not as, none of my experiments look, that you could buy them from any manufacturer. It's not clean at all.
Well, I could tell you that Corona motor was much cleaner than mine. You did a very good job on that.
No, thanks. It does take a while to do these things, but just don't give up. That's the thing. We will get there. Whatever we're looking at, we'll succeed. On the Corona motor, in the end, like you talked about a gearing system on yours.
Yes.
I think it was Robert Murray Smith. I don't know if you've seen his channel.
Absolutely.
He had a motor that you could print out and coil your own serpentine coil around it.
Really?
Yeah. So I did that to see what the effect would be. So you buy some thin magnets, and you just place them all in. It's all there ready. It's quite easy. And I connected it with my motor there, the Corona motor, and it started producing. So the next step is the ideal motor, should I say, is not a brushless motor, non-connection, only magnetic. That I think that would be the best option for such a small motor. But maybe with a bigger version, you could connect a generator to it. I don't know. I'm not there yet.
So the brushless motor goes in 3 phases.
Yeah.
You know what I mean? And then you got the motor you're working with, the Corona motor, went in 1 phase, right?
Yeah.
So you think by adding more phases, you can get it to increase the speed?
No, on the printable motor that's connected to if we call the Corona motor the generator.
Oh, okay.
The primary mass mover, or whatever. And then this motor from Robert Murray Smith, that was a DC motor that you could print out. And I was trying to make, the whole point of it is because I can't have an antenna and draw the energy in as Laser Saber's design did. I had to build what I call a lightning box, but I would try and see if the amount of movement through spark generation could move mass enough that would drive a motor to make a DC voltage that could then be collected and used as the input. So if you like an old motor on a car that had to be started, then once it's going, that would have been it. And then you could maybe add something to that to take your energy off. Not for free, but more.
Well, not to change the subject too much, but I was looking at a patent the other day, and let me see, Troy, I forget his last name. He was doing big wheels, on the outside. And then the magnets were just like pistons, and they were going up and hitting, repulsing. And every time it would repulse, the big wheels would turn. And then it was like taking a merry-go-round and then pushing it every so often, right? And keeping it going. So once you got it started, it wanted to stay that way. So it would continuously produce more energy.
Yeah. Yeah. And I've seen that analogy with the swing and the child, isn't it? Is it the same kind of thing? Yeah. The rocking mechanism. Yeah. Yeah. It makes sense. That's what I'm looking at, I'm sure.
So that's why I was asking about the 3-phase on the Corona motor. I got it backwards. The motor was the Corona was the generator, not the motor. I was thinking, man, 3-phase in that, it's like one person pushing, two person pushing, third person pushing, right?
Yeah.
And I go faster.
Maybe it would, if that's, we're not even close to what these things can produce. It's just the beginning phase. So, and maybe that's another idea to pursue that could possibly work. Who says it couldn't until it's actually been experimented with?
So I love the fact that you went from that and you went to like that Tesla coil with the rod down the center. So now you have to pull the energy out of the earth versus the sky.
Yeah.
So
because and again, when you're looking at I think everything we're looking at, even though we get frustrated, it's placed in front of us to try that experiment. Then we make that observation, then we make a correlation or connection to the overall, to the end goal. And I think this Corona motor is a next phase with static electricity. And I think, rotation, static electricity, magnetism, as you've talked in your previous casts, is all connected and they're all intertwined.
Well, let me throw you a curveball here. The conversion for energy out of the ground and the conversion for energy out of the sky are almost exactly the same in putting it in capacitors and then changing it just a little bit. You know what I mean?
Yeah.
Breaking that symmetry of it, and then you're good to go to use it as regular power like we would know it anyway.
Mm-hmm.
So it doesn't matter. So when you get up in the sky, if you have like a UFO shape and it's spinning around, it's pulling in that energy from the area.
Yeah.
So you're going to be able to use it to pull a little bit of over unity up in the sky because the energy is readily available.
Yeah. It's the sea of energy around us. It's everywhere. If we can stick a rod in the ground, in the sea, in the air, and just pull it out, it's just to find the way of exciting the coil enough for it to open the reservoir, if you like a tap of energy. That's how I visualize it. It's just
absolutely. Well, I kind of see it as like there's a field above us, field below us, right?
Yeah.
And we're stuck in this null zone in the center. This like center plate
capacitor. Yeah.
Yeah. And we're all saturated, and then you only see it in lightning strikes where the tendrils come up from the ground, and then you get the ones coming on the top, and then they start striking each other like a capacitor would when it discharges, right?
Yeah, exactly. It's just the same. It's as simple as that. As we talk about Don Smith, and he always says the two plates and puts electrode at the side, and it's having the same effect going through the air as it would. It doesn't lose anything the other side, even though you have the air gap. Mm-hmm. And take it this way. Yeah, we have the atmospheric pressure and the earth. It's the same. It's all the same.
I think one of the things people lose in this is we're in a positive pressure environment, and we tend to forget that every time when we look at things. So you go, well, man, I got to build something in a zero pressure environment. Well, why? Are you out in space? Because we're not. You know what I mean? Let's just
Yeah.
build it here. I mean, it's good enough. But yeah, I like that when you do those 2 plates. But then, oh man, you could build up a lot of pressure if you coat those plates, right?
Yeah.
You put a little spray on them, coat them, and then they start bringing in, and then they start shooting energy out the sides of them because they can't spark over.
Yeah.
You stop the effect, and now it has to build pressure and pressure and pressure, and eventually you get a laser out of that thing with a simple DC flyback.
Yeah. I'm totally with you there. That's we do not want the spark. We want what comes before the spark. The birth of the spark, if you like.
Yeah.
You know, can I tell you something a little bit woo about?
Oh, absolutely. Go into the woo.
Okay. So I started, how I first started, I'll take you there.
Okay.
There was a guy called Cliff High. Have you heard of him?
No.
Okay. He by computer analysis made some bots that he would send out, this is years ago, onto the internet, and all the words that we were subconsciously speaking, these bots that we wouldn't use every day, we'd use a new word for something. Apparently it's all connected. These bots would come back into his algorithm, and he would form a future report, it would be called. So in his future report, he stated that the free energy electrics movement would be started by somebody in Russia, or one of the Russian countries. It was actually Georgia where I found Kapanadze, for example. That was in 2008. And this was a coil that he stated that he'd been working with Tesla designs and plans, and he found a system where using the ground energy, he could draw it back and have the system continually running, almost like a reflection, if you like. Maybe that's how it works. I don't know. But I found out at that point that he was using a huge radiator, Kapanadze, if we talk about the first design. They put a huge radiator, car radiator, in the ground, covered it with soil with 2 leads out, and just watered the area. So the 2 grounds will go into the same point. And if you invert that to a Tesla tower, you'd have an aluminium or a metallic top dome, which would be drawing it in. So he put it in the ground and was drawing it from the ground, the negative charge. So this started stimulating my interest for years, but I'd always come up against a bit of a wall. So then somebody suggested I talk to a psychic. So I thought, okay, I've been reading about a guy called Edgar Casey.
Okay.
And he had, if you go on their website, he had so many thousand psychic readings, also going backwards in time. Whether it's true, nobody can validate that. But he was also a psychic doctor. So he would prescribe medicine or different alternatives to people to make them better without even seeing them. He only needed to know their address. This was way back in the 20s, I think.
Yeah, it was a while back.
So getting back to that, I thought, okay, I spoke with somebody. One of these, we can't see past the. So I gave up with that. I thought this is a little bit crazy, but later on, I was connected with a group called the NUI, NUI group. May have heard of it. They were also doing something similar to what you're doing now, not with regard to the experiments, but more to find the solution to what we're looking for. And she was, should I say, she could put me back regression. Is it hypnotic regression?
Okay.
So she wanted to ask my subconscious the answer to what I was looking for today. So weirdly enough, all of a sudden I'm faced with this huge lion looking at me straight face to face, and it's covered in an armor, a golden armor, in front of a waterfall, and the waterfall has a transparent egg shape inside of it, and inside the egg shape was a little a Buddha, if you like, and he opened his hands and showed me a blue flower. So after this, it's like, okay, what is that supposed to show you? So I see it as the flower is the spark, the plasma. The egg shape was the field around it, and the waterfall is around us where we are now. It's everything's falling down. The particles of water or whatever are falling around us, so we could maybe make the spark in the air because of the water particles. Yeah, it's just, and that from that I've been making some. My mind's been open to different possibilities. So yeah, that's where we are today.
That's so cool. I always, every time you get the lion, the representation, it's a God reference.
The lion is.
Yeah, that's the way I see it anyway.
Okay, yeah, I never had an interpretation. It was just, that was it. Thank you very much. Have a nice day.
Well, that's pretty cool, though. You get the plasma and then the flowing, so it's a representation of it's always flowing in nature.
Yeah.
So, yeah, I can see where you get it. The antenna in the ground from the radio, and then you pull right out of that. And so when I ran the energy into the mud, when I did my experiment, it was pulling the energy into the mud and grounding it, and I was getting the frequency more than anything. So it would have effects on plants that were around it. It would help them grow and stuff like that. When I got the plasma, you could have too much of it, so it would like kill the seeds in the plant. So the frequency itself is what I needed. I needed to get the frequency that the plant liked, that it was in tune with, so that it can grow better.
Yeah. That makes sense. Just as we're talking, it's the birth before the plasma or the spark. You know, that makes lots of sense.
So it makes sense when I did my Tesla coils too. So I'd start the first one, right? The second one would sit there, but with no primary on it. And you put the right frequency in it, and then you get plasma discharge on top and bottom. So it was basically telling you anything that you wanted more energy into that is this same frequency, all you have to do is ring the bell the right way. Get the frequency to match, and then it starts to affect the environment and things in the environment that match that frequency.
That makes sense. It's, that again, I'm missing the tools there. It would be interesting to see the frequency changes on different devices as we're messing around with them, and go back after filming it to say, okay, I didn't need to do that. I didn't need to pull that out, or I didn't need to move it this way, because the frequency at that point showed me its maximum potential, or yeah, that's interesting. That could be something to play with, I think.
So let me give you a little bit on this. The frequency to get there,
Yeah.
you could light up light bulbs at a distance. I can go 5-6 feet, no problem, and get the other one to run just with a secondary coil. And without a ground wire or anything, the frequency has to be, how do I say this, within 20 kilohertz on a Tesla coil. So but the more fine tune you get it, and you get closer to what the frequency of that coil really is, then the energy you put out has to come down, because the energy in the room starts to pick up.
Yeah.
And things around you that are metal start to get hot to the touch. And you could put your temperature meter on them, and they're room temperature. But when you touch them, it's like a big RF burn. You're getting a lot more out of it. There's an explosive amount of energy that comes out of this. Mine right now are within, say, 12 kilohertz, or somewhere right around there, and they are monsters at 8 volts. Plasma at 6-7 feet is not a problem, and that's with no primary on the second one.
And you said there's no earth connection. That's just through the air.
That's just through the air. When you put in an earth connection and you do the calculation for it to make sure that the frequencies are right, it starts to pick up. You're getting 30% more easy.
Okay.
And it acts like a pump to the earth. So it's like ringing back and forth, and it's like pulling the energy out of the earth like a pump.
I've got something for you now.
Okay.
Just a second. I printed it out. It's basically one of Tesla's designs, or it was his collection method. But I ran across it online. Some Dutch Tesla enthusiast has made a tower, a Wardenclyffe tower. Here we go. You've probably seen this design before, haven't you?
Oh, absolutely.
Right. But we're missing a third coil. How he describes it is the first one, which has our ZVS would be power in it, would be the exciter coil.
Mm-hmm.
Then this would go into the ground, or into the same large metal earth point as with Kapanadze, as I said, with his radiator, if you like. It draws the energy back up. So we're having a connection at the top here, and in here it acts as a closed circuit, basically, even though the earth means it's an open circuit. But as that's closed circuit, then there's a third coil, which is a coil that has just an antenna and an earth. And that's the one where you pull the energy from. And in the designs, it's a clockwise winding, counterclockwise, and counterclockwise.
Is it like a null zone coil?
Yeah, I think so. Like these coils that on this design is just a pancake coil. Because I think there's plenty of different ways you can do the same experiment with different windings. But it's the third coil. It was interesting to me. Nobody talks about the coiling of it that's wound counterclockwise. So you have the L1, the primary, which is clockwise on the first exciter. If you like, while we're making our Tesla coils, you had the primary coil, which is clockwise. The secondary coil inside, which the inductive coupling, that's clockwise. And he had it with an antenna and then down to earth. The second one was counterclockwise wound. So maybe there's again, there's the 0 point, the bifilar coil would be an example, wouldn't it?
Yeah, the bipolar bifilar.
Bifilar. Yeah, they all have the windings clockwise, counterclockwise, I've found on some of these. Yeah, it's interesting. I know we can go down other rabbit holes.
Well, let's go down the rabbit hole. I just did a video with 8th Center, and we talked about orgonite, and he had a winding that was very particular. So in Ireland, they have those big houses they used to make in the dirt. So you see all the different layers that are on top of them, and it looks like a hill.
Okay.
And then it resonates in there. And then in the front, you'll see rocks on it, and it has a very specific design of swirls, right? So, yeah, you see it's like a yin and a yang on there.
Yeah.
And they're swirling to the right, swirling to the left. And when you see that coil, there's two wires like a bifilar wrapped around one another, but one vortex is up and one vortex is down. That might be the best coil to try in this thing, in that null zone right there. Because from what I understand, in that null zone, you can pull out a lot of energy because everything's pulling to both sides. You got your ground from your Tesla coil pulling up and in.
Yeah.
It's also vortexing energy from the top. So it'd be very interesting to see what that kind of a pickup in the center would be.
And again, that just makes sense. The null point, the 0 point energy. Why couldn't it just be as simple as that?
Yeah, because when you start up the other coils, they actually turn into bipolar Tesla coils in that they expel the energy out both sides of it.
Yeah, and while they're doing that, I see these coils. If you imagine a spring and a plate, it would be the outside force of the atmosphere and the earth is pushing like a spring, but it's fighting the spring. So as we excite the coil, it pushes that spring up, and because you have a little force, the huge expanse of the atmosphere then pushes back down to balance itself.
It's what is it? The transverse goes this way, longitudinal goes that way, but it goes in a spring.
Yeah, that just makes sense, doesn't it? Why he was working with coils that way.
Yeah, when you get two people that have done the same experiments and see it, then it makes a lot of sense when you start putting the little factors, on the sides of it.
Yeah. I like these conversations. The thing is, I live in a world where nobody wants to hear anything I want to say about this. Their eyes glaze over after 5 seconds of my excitement.
Oh, yeah.
So it's really refreshing to be able to chat with you, Nathan. Thanks.
Oh, it's the same way, man. My wife and my kids are like, whatever, Dad, whatever you're doing. And then, I turn on some of my Tesla coils and their speakers start going off in the room. And they're like, okay, what are you doing now? Because now you're affecting my life. That's when they care.
Yeah. Otherwise, you keep going. Yeah, I know. I know why I do a lot of my experiments with batteries is because I've had the same experience with frying the circuit boards in the house. I wasn't popular.
So there's a little bit different when you're running from a battery versus the wall power. Have you noticed that at all?
Yeah, definitely. I know there's the chemical differences in the battery versus to the power from the wall. There's a lot of differences. There's also, it's difficult to make a correct analysis or a good measurement, because the factors of the pumping energy from the wall will give you some different reading as opposed to what you have in a battery. You know, okay, I have this amount, and I can measure that, this amount in and this amount out. If we could do that, then we have over unity, which you've probably seen it yourself. I've seen it many times. That it is there. It's easy. It's so easy to make, but you can't. The difficult part is to explain to somebody that that's how it's working. In the laboratory where I work, it's full of the engineers that know everything about nothing. You know those people, right? And even though you're supposed to be educated with an open mind, it's not, because when you're educated in that structure, that's it. It's a closed system, and I think that's why and you are people like me and you are possibly the ones that's gonna have a better insight into these things we're working with than these people that have been educated.
It's the engineers versus the physicists, isn't it?
Yeah.
Like we actually build it, and you describe what we build, and then when you start describing something that's not built yet, it's very hard to translate it back into something that you can build without knowing the information first. You'll end up with a project that looks nothing like what you were describing.
No, totally. And they can't visualize what we're trying to explain to them. It doesn't matter how we explain it. They have a tendency to close the door.
I've seen a system right now that's completely over unity, and they've all looked at it and they don't know that it is. It clearly defines every single part that they were looking for in their experiment, and they just don't know what the experiment looks like, and it's lost to them. They can't figure it out, and I'm sitting there going, "It's right there. I seen it last week. It's right there."
And that's why it's refreshing to come and talk to somebody that's got the same vision, if you like, and is looking at the same experiments. It's so it's like a symbiont. It's easy. You don't have to really explain too deeply what's going on. The picture just flows backwards and forwards. Yeah, that's how I have it. I think it's cool.
Well, once you start seeing the negative in the ground, right, and you start realizing that you're pumping the energy out of the ground, then it's not shocking to you when you go over and you take a Tesla coil that it has the field flipped on it. So it's already got the rod in the center, and that's where your energy sparks out of now, right?
Yeah.
Well, now it changes that energy. So when the ground rod comes in next to it, the energy comes out of the ground rod and into it versus going the other way around. Because usually it would just spark over your ground and go back down. Now it's coming the other way, and you're using the opposite side of the field. When you can see something like that, it's no longer surprising. It's like, all right, we know the field's already there.
If I had an analogy like we have the Earth here, and we're this very small thing on top of it. But if this is filled like a reservoir with energy, and then you invert it, and you put the guy, the Dutch guy that put his finger in the dam to try and stop the water. Yeah. I see it as the same. You have, if you only need to start that mechanism, and it should be easy for you to draw whatever you want out of it.
Yeah.
So the over unity is there. You're just exciting. You're using energy to excite the mechanism to open the tap to bring out the energy. That's how I look at it.
We just kind of got to realize what a Tesla coil is. Yeah, it's an air core transformer, but it's also a pump. It's literally designed to be a pump. And we don't think of it that way because we think of fluid pumps and things like that. You're not thinking of energy as a pump. No. We don't think of energy in that term. And it's once you get it down to that term, you're going, okay, well, this is fairly easy to understand. Now, which way am I pumping it? And which way do I need to draw the energy? And then how do I pull it out? How do I make a draw to it? The draw is very simple. You just have to have a little bit of a light and going into your capacitors, and then it pulls it right into there, fills them up. You can do whatever you want with the energy at that point. And what I like about the capacitor aspect versus the battery is you could say, well, the battery is charged. Well, you say it doesn't lose a level. But people have a hard time understanding that. But when you say I have a 0 in my capacitor, now it's fully charged. Yeah. Then they go, oh, well, you got some energy there.
Yeah. Yeah. Have you seen the Kapanadze or my last design? I'm trying again with the third coil, which is a bifilar coil. So I have basically I have the ZVS driver, then I have the L1 coil, which is the thick copper coil. Then I have the secondary coil as a thin wound coil from top to bottom. And then the third coil is bifilar coil, wound clockwise and counterclockwise. But I haven't connected it to, as I talked about this, I haven't connected all the 3 coils yet to the ground.
Okay.
So I'm wondering that these 2 will make the circuit complete with the ground, and then the third I can just put in the ground anywhere in the immediate area and be able to draw out a good amount of energy.
So which video was it? Was it the one with the aluminum foil and the coils?
Let me think. No, it's one where I'm filling up a capacitor. There, This will be, and you can see that's 50 volts in 2 seconds or something in the capacitors. Yeah. I don't know if I've connected that one. No, that's another one, but that shows you from the ground the amount that's pumping in to light that halogen light.
Let's go ahead and play it for a second and see what it looks like.
Yeah. Okay. Just playing around again today. Same setup. I just want to show you. I found a halogen bulb, 350 watts, 240 volts. Again, we're just using an 18 volt input DC. After that, I'll show you a test where I connect these Schottky diodes. Has a rectification of the I'm not sure what the wave is, but basically we come into this capacitor, and I've also got some Christmas lights lit up just to show you. And 3 seconds should give us more than 50 volts. This is a DC, the 12 volt DC motor there. You'll hear running. But first, the halogen lights.
Oh, nice.
And that's from the ground. Watch out, Nick.
It gets you right there. Oh yeah.
Okay. You can see that, can't you?
Yeah, a little bit of smoke.
350 volts there. That's a Smoky Joe. So, sorry, 350 watts, and possibly more than 240 volts, because that's almost burnt out. So Next, I'll show you, we connect the bifilar, which is L3, as I call it. You can see those outer legs connect with the Schottky diodes. So we connect, as you know, with your bifilar, the two ends are connected to the negative. Kind of.
Yeah, if those things ever agree with you, man,
Stay with me.
so I got the ones with the little clips on them, so you just clip them on. That drives me nuts.
Yeah. I do a lot of this, so it's just, okay, I got this idea, let's do it now. 3 seconds on the battery. 1, 2, 3. Hold on. You can hear the motor running.
Oh, yeah.
This is the DC. Right, I'll show you again. 1, 2, 3. So if we can have a stack of these set up and then transform them down to a lower output. My idea was that we could maybe take the AC and rectify it back in and see how long it would, how long the power would go around. But that's all I want to show for now. The difficult part that I've seemed to have is there's too much energy. You know, if I'm ever going to pull these to loop these systems, I have to also have the same amount of energy as I'm putting into to power the ZVS, for example. So that in the 50 volt would blow the ZVS. I've used a couple of those.
So how many amps are you getting versus what you're putting in?
Yeah, that's another thing I haven't measured yet. But I think something in these, we talked about capacitive effects in some of the coils. Mm-hmm. And maybe looking at a bifilar coil and the two ends that were connected, that operates going into the earth of the capacitor, the negative side of the energy of the coil. And if this is, I think this is where we're getting a lot more energy. This seems to be where I think where we're able to connect the negative energy through the system. It draws in somehow, or it just maybe acts as an alone system. If you talked about vortex, mm-hmm. If you have one coil here, and they're operating, turning in different direction, opposite direction, the collision point is the center, which in that is the two coils, which is the earth. So yeah, I don't know. Maybe with looking at these things, observing them, we will find out what they're actually doing.
Yeah. Yeah, I did the motor run as well, but it was a bigger motor, so it didn't last as long.
Yeah.
And my fill-up time took a lot longer.
Yeah, okay. Did you have Schottky reaction, fast reaction diodes?
No, I didn't. See, that was one of the problems I had, is the diodes are too slow.
Yeah, I'll try and send you the details of them if you want to try that. That should speed things up on it. That's what I found. A normal rectifier, it seems to build up more heat. These diodes are that fast. They don't heat up. They just let the flow out. So that's why I've had a better success with those.
There was another thing I wanted to talk to you about. Was I was watching Cold Energy from Michel, and he was showing, I forget the inventor's name, but he took two pieces of pipe that were just copper pipe. He put a spacer in the middle, so something in there that wouldn't conduct over, right?
Yeah.
He puts them together, and then he wraps the winding around the entire thing. Okay, and in that, he's able to get a lot more current out of it. It's a cold current device. So my thing was thinking with this, we're getting the voltage. Now, what if we simply had that rod in there? Could we get the current as well? So
that makes sense.
Half-inch copper, you know what I mean, and just cut it, and then we can adjust where that split goes.
Yeah.
You know what I mean, on each side, and we might be able to pull the cold current along with the cold voltage in order to get this thing to give us enough of what we want. And then all we have to do is change the frequency on it when it comes out. So if we put it into a trigger circuit, and that'll allow you to put frequency into it, you're going to be able to change your voltage and amperage like this all day long.
Yeah.
So that might be our answer to pulling it back into unity, the loop.
Yeah.
And then all we have to do is pull the capacitance out that's extra.
Yeah. Yeah, because that can be, you can split the positive if you like. I've done an experiment I've made that many experiments there, but the ones with bifilar, where I can split, I split the positive. So there's enough to keep I have a DC to DC converter. After the 50 volt in the capacitor that I have, it goes then to an inverter that gives a normal 250 60 hertz power out, and then the other side is recharging the battery from the input. So that it actually, here's an observation: by doing that, it slows the amount of output from the input battery.
Really?
Yeah. That's a definite observation I've had there. It I thought at some point, yes, I've got this looped because it held the voltage of the battery input, didn't drop for a while, and of course, as I was siphoning off half of it, it then started to go slower down. We were using a bit from the battery then, but there's a point where it stopped it and the system's still producing. So are the coils holding a kind of, are they a capacitive effect, or are they drawing something from the center, the 0 point or the null point? Or these weren't connected to Earth, by the way, these ones.
Okay.
So that was another strange observation that might maybe it draws it in from the air, the above ground atmosphere. So there's maybe different ways, as we say, there's that many different variations where we can pull this energy out.
Well, let me run this by you a little bit in the woo right here.
Yeah.
What if we're not making energy like we think we are? You see, we use volts and amps and things like that, and we think that we're creating fields in order to build an energy field or pull an energy field in from the magnets rotating, right?
Hmm.
What if we're just pulling in the energy from the environment? And that's all it is. And we don't really realize it. We think we're in this little locality system right here, but really it's just pulling it in from everywhere else. Because energy can't be created or destroyed. So how are you creating it in a generator, right? So a little bit more thinking on it would say, when you're just creating a vortex that allows the energy that's around it to be able to be used by it.
Yeah.
So it would go more in line with the energy in the atmosphere, go more in line with the energy below the surface and how they're functioning. And maybe we're at a very poor level in the parts that we chose. They're functionable, but they're not right.
Yeah. Yeah. And of course, if we used all the parts that were used in the original experiments, maybe we'd have a different result, the results that we're looking for. we're experimenting with modern parts. We're trying to remake the wheel again, aren't we? Instead of trying to find the exact parts that they used in their experiments, because you're going to have a different result.
Yeah.
Doesn't matter how you're doing it. We're not going to have the same results as they do because we're using different parts, aren't we? So we're just going to have to find our own way, and I'm sure we will.
Well, let me throw this another curveball at you a little bit.
Yeah.
What if we put the?
I'm ready.
What if we took out the in line with the power we put in the trigger circuit? So all it is we're putting a rider or a frequency onto whatever we're putting in, right?
Yeah. Yeah.
So then you put your frequency generator to that trigger circuit, and then it allows you to control your Tesla coil in a way we don't do it right now, or your generator device there. Same way, we can add a frequency to it. So if we're looking to take a second coil somewhere, if we know what the frequency is of it, then all we have to do is ring it, and we can get extra power.
Yeah.
So if you think about it, I just have to ring it the right octave, whether it be the first, second, third, or fourth. I bet you if we started winding coils based on their octave when we did it, or basically, say you take a A and you get every single variable of A, you know what I mean? A sharp, A minus, whatever, going down the line, then it would actually give you the right ring in every single one of them and build potential energy till you get to the last one and pull it out. I think what we're missing is that little bit of that circuit change. Instead of getting the energy it wants to give us or the frequency, we need to provide the frequency to it in order to take advantage of the power levels. That way we can drop the amount of power, how do I say this, and make it like a Tesla dynamo where we're putting in maybe 50 hertz, 60 hertz into it, right?
Yeah.
And then it builds up a tremendous amount of power, and then we shoot it off at a very high kilohertz or something like that, but we retain that massive power that it had in the beginning dynamo.
Yeah. 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 That makes sense. That is there anything out there? It's not a pulse width modulator, is it? Is it something simple like that we could power these coils with? Where we could adjust the frequency if we add a frequency generator.
I do it with one transistor. I have a Slayer exciter circuit that I use, and it runs on a PNP, so it runs backwards in the circuit. Yeah. Instead of through the positive, it goes through the negative. Yeah. And that thing will run 40 volts all day long. All day long. So this project we're working on here, we can get rid of a lot of the problem with the heat with the ZVS, the losses that come into it, and we can get massive fields and energy out of it at a lower level. Yeah. So that's and it's a couple parts. It's a 47 ohm resistor, 47 K ohm, sorry. And then it's a one transistor.
Simple.
2SA1962 is, I believe, the transistor on that. And like I said, it runs in the negative. So it pulls the energy of the negative, so you're not getting the heat into it right away with the loss. Yeah. So it's more efficient. So it's pulling through that system. But that would be it. And then, like I said, a simple little device here. I'll show you one. This right here, you just buy them on Amazon. Yeah. It's a little trigger circuit. Yeah. And they're about $12. And then it allows you to put frequency in. The power goes in, the power goes out, frequency goes in here. And there you go. You're set to go. You could take a little $10 chip of a frequency generator, connect it to this, and you're set to go. I mean,
I have to get one of those. Or both of those items. Could you maybe
I'll send you the link.
Send a link. Yeah, that would be brilliant. Yeah.
Yeah. So that right there is a cool option, because then now you can start changing everything. I do it in my DC flybacks. Yeah. I can change the frequency, and what you'll notice is we're changing the amount of amps in the spark. You'll see that whiteness that you see in there for all that amps. It starts to go away, and you get a lot more purple in there. Yeah. And it starts to thin out.
That's what you want, the corona. That it is like with the Corona motor. It works as soon as you get the spark over, it loses momentum.
Mm-hmm.
No spark over, the pressure is just where you want it for it to force the how they explain it is you have the positive, negative on the fins,
Mm-hmm.
and it forces the positive onto the rotor. Then there's a negative that is the first path for it to connect to, so it pulls the rotor. So it's again, it has to be the pressure has to be that color, the purple Corona. That's perfect. Yeah. Then there's no loss.
No, it gets a little bit more efficient, doesn't it?
Yeah. I'm sure if I want to then connect a generator to it, then there'll be more force with that circuit that you're talking about, and I have less input. Then I can draw something from that generator back to power the chip.
There you go. Exactly.
That's what we're looking for. Then it's a loop system. So and maybe the aluminium fins, as I call them, they're also using the environment around it. I think, could that also be, as it's moving along, it has to form a kind of a vacuum behind it. So every time you're drawing something in, you're having to draw the environment in for that to be what it is.
So again, back to my analogy, maybe we're thinking of the motor wrong, right?
Yeah.
Like the Corona motor shows you pulling the environment right into it when you put it up that high. And we're looking at a motor of we're building it, and that's what's providing the energy for it. But that's not really what's going on there. We're triggering some kind of vortex to pull the energy into these devices. And I think that when we get that straightened out in our heads, you know what I mean? I think we'll be better off.
It makes a lot more sense instead of saying there's this. It also makes sense if you want to start writing a new law. I'm not saying that was it, but if in the future there's a new law that states that the environment has a huge part of in physics, like we talk about, you have to. It's going to be there. It's just a matter of time.
It's one of those things where it's like, as an engineer, we could say, okay, we can loop the system, and that's our primary driver. Yeah. But that's not where we're getting our energy from. Our primary driver is just a circuit to run something in order to get a secondary effect. See, the effect is we're getting the vortex. And this is one of the hardest things for people to understand when you go, I want to build a room temperature superconductor. And they go, well, how do we get so much energy in there? Well, the energy is not from the primary mover. It's what the primary does to the environment, right? Yeah. Because you're not creating or destroying energy. You're just using an energy you didn't think you were using, and you're amplifying that. Yeah. It makes the most sense. You can't draw. If we take, the law today is you can't get any more out than you put in. And that's correct if you have a locked system. Yeah. If you're not taking into consideration the environment, then which you mean a vacuum chamber and put this thing in there and everything else, which is not what we're doing. We're in an open area. I put a small one in a vacuum chamber. Did you really? Yeah, and it breaks. It stops. You let the air in, the environment starts again. It has to, and it's not that we're using a spark in any way, because it's coming directly from my box in the capacitors directly into the motor. But it can't form, of course, because there's no air. So the dielectric's gone.
when the vacuum takes the air out. Yeah. Sorry.
It's like taking a component out of the system, isn't it?
Yeah, and it's the environment. And again, you've seen it from your earth connections. It's the environment that's and the center coil, the center rod in your coils. It's drawing. It's all the environment. That's what it is. I'm an environmentalist now.
I think it also has to do with, in some of these systems, we're not bringing heat into the system. Like it's a negative to it. It just burns off our energy with the hysteresis, right?
Yeah.
So we want to bring a little bit more room temperature into the system so that we're not losing any energy, right? So if we can combine the vortex with the absence of the loss of energy, then we're good, man. We're starting to hit numbers, 90% efficient that we should have been hitting or higher. And then when we take account the environment, obviously we can get a lot higher than that.
Yeah.
And the temperature differential between, the outside and inside of the coil makes a big difference in that. And I don't think that our normal motors take that into account, or generators. They don't mess with temperature at all, so they wouldn't know. No. All that heat is all your loss. There's, you could put a secondary one out there to collect the heat that's coming off of these things.
And they're also absorbing the fields by the amount of metal that are in these transformers. We just have nothing in there. As we say, it's nothing, but it's the best conductor, which is the air, isn't it? In the air coils, I'm talking about. Sorry, my mind sometimes goes on to the next step, so I do apologize, Nathan.
No, it's okay. We're good to go. I kind of jump around myself a little bit.
Yeah, that's maybe the nature of it. That's why you can think ahead when you're doing these experiments. You already have the next one planned out before you're starting the first one. So it's it's a hard process, but I feel positive about it, especially on this connecting with you on here. I hope anything that I've been able to share today can stimulate somebody else's next step. That's my hope.
Oh yeah. Well, I don't think that's a problem whatsoever, man. People just have to open themselves up to the idea that things can be different than our structure provides now. I mean, how do you get a genius out of the system? Because he doesn't use the system. He's not part of it. He doesn't get it. He sees things in a wholly unique pattern to him, and that's how you get a genius. Yeah. That's what people don't understand. They keep telling you to conform, use their rules, use their words. They're not understanding. We're not getting anywhere with them. We're done with that. Well,
you can see the amount of advancements in the last, 80 years, because we all kept in their box. There's been no huge steps, has there? Not anything that we can see. Energy, they're stating we can use windmills. Windmills cost and upkeep, and the amount of energy that comes back. It's ridiculous. Over here, our energy bills have tripled since we want to be the first movers in the world in Denmark with energy. Yeah. But they're doing it all wrong. They're just still in this box.
It's like they got their chisel and their hammer and they're creating the wheel out of stone all over again, right?
Yeah.
But then they're killing a bunch of dolphins and whales in order to do it with all these frequencies they're putting in the water. Yeah. And they're not realizing it. Hey, we want to be environmentalists, but hey, let me put this big windmill in here and let's ruin the life that's in the planet.
Yeah. It does.
Yeah, there's no question that it does. It was a bad experiment. And then by the way, we're not allowed to have a solar panel better than what 20% efficiency. So, yeah, how many times have we invented something that's way more efficient than that we should already be using?
It's all about the money.
Yeah,
it has to be. It doesn't take a rocket scientist for us to find out that that's what it's all about.
Yeah, well, I mean, look, I got solar panels on my house. If they were 80% efficient, I could take half of them off at least, and it's better for the environment, for the recycling. It's better for all of it. Maybe they'll last longer at a better percentage, and it'll take the stress off the electricity grid. I live in California. We have brownouts all the time for air conditioners, it's like, why? I don't understand why. We have the technology to fix this.
Yeah.
And
maybe it's many years ago when we were manufacturing our own stuff, it wouldn't break, or if it did break, we had a guy that could come and fix it. Yeah.
there you go.
Today it's made to break so that you can buy a new one at a cheap rate, and it doesn't make any sense. I mean, isn't that bad for the environment? I don't know what is.
Yeah. Well, I tell people all the time, they go, I want free energy. I go, well, okay. You ever built a little paddle wheel? And they go, no. Okay, well, this is a pretty simple exercise for you. Build a little paddle wheel, put a generator on it, take out the iron. You could just use the aluminum in there. And simply go over there and find yourself a pond of water. And it could just be your little bird feeder water thing, as long as it's about that deep. Go over there and suck on the hose and put it right over there to the top. It'll continuously turn that thing all the time, because the water always tries to equal the amount in the pond at all times with that pressure. So it'll continue to pressurize, and it'll keep running it and running it and running it all day long. You can have lights out in front of your garden all day with this, and you can have free energy. Yeah. So that's about as simple as it gets. I mean, we're doing it wrong.
Yeah,
we're not thinking of this. It's like a dam effect in a miniature form. We know how to do it. Why are we not doing it?
Are we stopping ourselves with what we've learned? Do we? Not us, but those that are supposed to be looking into this. Are they stuck in this educational field? And maybe they've had these genius ideas, but because it doesn't, it's not allowed in their worldview, then it's not allowed to come out into the public. Is it that, or is it a money issue? I don't know.
It's not a money issue. They already have it. I'm going to tell you this right now. The government already has it. And I learned this with some of the devices that we're building with, right?
Yeah.
If I could do this in my garage, and I'm working with a couple $100 worth of parts, or maybe $1,000 worth of parts, somebody with an unlimited budget would be way more advanced than I am. That's for sure.
Yeah.
You know what I mean? Or else maybe they just need to give me a paycheck, right? And let me go handle it for them.
Yeah, that's a better idea, isn't it?
They wouldn't let anything out of the lab. No. We can't let anybody else have this. It'll ruin our whole system.
It's very peculiar when we look at all these systems and patents, and I'm finding out that the patent office has also been corrupted. And so when we're searching patents to get inspired, there's stuff missing, or it's been headlined as something else than it actually is. So it's pretty difficult for us all, Well,
I just say put it out there on the internet. You know what I mean? Yeah. People could choose on their own, and we do, we just build it, put out the observations of it, and let's see how it works. Because a lot of times when we look at this stuff, it works how you would expect it to work. And I know that sounds funny, but you really get an idea after a while of how electricity flows and, what to expect out of this. So it's not really a big surprise when you get it right at the end. It's like, oh, okay, well, that was confirmation that I knew it was doing it that way, because I had always done it that way in the past. You know what I mean?
Yeah.
but I just thought of putting the right step in the next part.
It makes, and you talk about what they did in the past. And if we look at, for example, the pyramid not as a tomb, but as a generator, it actually makes sense. I saw there's a town, Sarak. Anyway, I forget the name. It's an Egyptian town not far from the Great Giza pyramids. And underneath they have sarcophaguses made of black granite stone, huge black granite stone. Well, all you need is a static generator that would actually just something to collect it en masse and put it into these granite chambers, because they'd act some kind of like a capacitor.
Well,
it just makes so much sense.
Let's go back to that water experiment, and the water with this energy that we're doing, pulling it to the center.
Yeah.
It works with the granite because of the quartz in it.
Yeah.
And it's pulling more energy. So a capacitor, absolutely. If they filled that chamber with water and that was it, and they use this type of energy in there, they can get a huge capacitance out of that quartz.
Yeah.
So that would be their caps and their system to run their main system. Yeah, absolutely.
Because I also looked at the when the hieroglyphs inside these chambers, there's no soot on the ceilings. They didn't have a candle and have a guy painting. There's nothing in there. It's totally clean. So they must have had a light source, which wasn't fire. So that would have been an illuminating bulb of a kind. That could be quite easy for them to make. Or again, if you take the pyramids, maybe that was made on a previous technology. It wasn't even the Egyptians that made it. They bumped into it and were just in the area, and that was already being made millions of years previous. A different. Yeah, you can, again, the rabbit holes, they just keep going deeper and deeper down.
Well, like I said, I was just doing an interview with 8th Center, and he said that the things were Atlanteans.
Yeah.
And that they were, 20,000 years ago is when they had the pyramids back then. And even further back then, before that. And the Egyptians came in and they were operational when they got there.
Yeah. Yeah. Well, there you go. Yeah.
It makes all the sense in the world, man. There's so many layers to that puzzle over there in Egypt that every time that we look at it, it gets better and better. And by the way, we don't need to pour any chemicals down in the holes like they suggest. It's already there.
Yeah.
The process is so easy to do once you understand it. We're dealing with resonance and frequencies and the energy that's correct, that matches it, that goes through the earth. Now we're getting to the right side of things. And it's starting to be so easy to figure it out. I think that's why in the community now, everybody's coming back to it because they're starting to figure this out. Hey, we made a breakthrough that'll get you here, right? Now that you can activate the crystal, work with the crystal, it's not just a tap it on one side and it taps back and you make a nice watch. You know what I mean? That's not what it was used for.
No.
We use the geometry structure of the crystal itself now. Now we're starting to get somewhere, right?
Yeah. Yeah. I mean, sorry, carry on.
Oh, go ahead.
No, talking of the crystals, the geometry within the crystals is kind of refraction. And if you have a crystal with more sides within that crystal, then the light would refract, or frequency or whatever we're going to put into it will magnify even more. As you talk about we talked about the saltwater capacitor, crystals in the salt. and that capacitive effect is increasing what's put into it.
Mm-hmm.
Then a crystal would act the same with frequency, just the frequency, a surrounding atmospheric frequency maybe, and that would be held in there for. It would just be building and building and building.
It's
It'd
like we're looking at it almost like a two-way mirror, but in opposite. So we can see through it, but in the inside, it's like a mirror where it's bouncing.
Yeah,
the energy constantly, right?
Yeah.
And it works its way through. And you were saying the structure of it. I'm building. I got one sitting over here, a geometry coil built specifically for the hexagon, in order to translate to that energy. And then when we get it going, the center of the coil will be just like the Tesla coil, where you could put the rod down the center and it goes right in there. But why not just have the whole thing in the ground?
Yeah.
Why not just pulse this thing in the ground right then and there?
Yeah.
And we could get a lot more energy out of it. That's what I'm looking to do with it. And then the crystals, man, they put off a frequency. Here's a crazy thing. If you take some and you bash it up a little bit, put it in a little container with water, and then you can put your voltmeter in there, it'll tell you that there's millivolts of energy, right?
Yeah.
Well, if there's millivolts of energy, there's also frequency that has to be associated with the energy.
True.
So you're going to get a frequency out there. It's telling you what it wants. It's not lying to you. It's just, here it is. You know that if you have energy, you have frequency. The two go together. So why not just get the same frequency like we're doing with our Tesla coils, you know what I mean, with all the coils you're working on, and let's just tune it in. And then maybe we'll start to get the understanding of the Ark of the Covenant, where we get the things to light up.
So it's the tuning, like a tuning fork, or I've seen the experiment with a glass and sending the frequency of that structure into the glass, and it can't hold the energy. It can't hold its form, because when it's being pulsed with its same frequency, the energy is just too much for it, and it shatters. So I'm wondering if, and that's just with the sound. So I wonder if we need to work more on the sound with a crystal. If the crystal is going to hold the energy like a capacitor from the sound, and if we find out, like you say, we need to listen to what the crystal is telling us. So the crystal's telling you the frequency that you need to reflect at it for it to build up enough capacitive, enough of itself's energy to maybe start lighting up or something. I don't know. Interesting.
Well, sound is the movement.
Yeah.
Frequency is what goes into the sound to move, right?
Yeah.
So if we think about it that way, then sound isn't necessary. We need the prime mover, so we need the frequency.
Yeah.
Right? Now, how are we going to communicate with that crystal? Do we do it in open air? Like you're saying with the sound would do it. You'd have to direct sound to it with the frequency to do that. But I think there's an easier way. Once we put the frequency into the water, water acts as the medium between the two. And then we can affect it that way, because water structures when you put positive energy into it, and then it deconstructs when you put negative energy into it. So now you have to just decide which one you want, and then let's put it in, the way that it's going to work. Generally with these things right here, they activate on the negative energy, not the positive. So we simply put the frequency on the negative, because the rod down the center activates with the crystal really well.
Yeah, because that's a 0 point. Yeah. Sorry.
Yeah, so we just got to put it in through there. I think that's a better medium. But I'll say that the monks may prove me wrong in the fact that they use all the trumpets in order to move the rock, because They're using sound itself to move it with the frequency in it.
You know, a dog whistle, for example, we can't hear that sound, but it still operates on a frequency. And maybe those trumpets operate the same. It doesn't mean that there's a massive, like a shock wave of any kind. It's something else. It's a frequency that's beyond our scope of listening.
Absolutely.
And that would make sense. That would make a lot of sense. You know, some of the Corona motor, for example, that bell that we heard in the video. There's something coming in there that's maybe that's the Corona motor was telling me that that's the tone it needs to work at.
So then take the recording of the sound and find out what that is.
Interesting.
You know what I mean? So find out what frequency it likes, and then you could go back to with the trigger circuit and put in the frequency that it needs, and then run the motor again and see if you can't get that thing to blaze out some a lot better sound, a lot faster motor.
Yeah, it's interesting because
I think that's what the problem is with our stuff. We get it to where we want a certain amount of energy out, not what the maximum energy could be.
Yeah.
And we don't tune our system like we would our guitar. And if we did, then we'd be way better off in getting the harmonics right and everything else in order to get these things to really start cranking out the stuff we need.
Definitely a combination of the two there. There has to be. That's another thing I'm definitely missing. I've always read about it and heard about it, but I've not implemented it. And that could be a part of maybe that's the key. You know, it's the harmonics key. Sorry, yeah. So
you could take a tuning fork, and if your coil is wrapped the same exact frequency as that tuning fork, you can strike the tuning fork, put it next to that wire, and turn it on.
Yeah,
and it will start producing energy.
Yeah, that makes sense. It's to excite the spring. Yeah.
There you go. To excite the spring.
Yeah. That's interesting. That would be a cool experiment.
The guy has already done it.
I'd like to see. It's out there, is it, or is it?
Oh yeah. If you give me a minute, I'll pull it up real quick.
Oh yeah.
I was just looking at it the other day in my stuff. It may take a minute to get there, but I will find it real quick. Yeah, and I'll show you the one with if I run across it first. I got like 2,000 liked videos on here, so. Oh
yeah, that's the same. everything you come across is okay. Liked.
Yeah.
You can keep going. That's interesting. Just a note, music, harmony, symphony. There's something there.
Oh, I think there's a lot more there. Like I said, with the Tesla coils, if one could turn on the next, why can't it work in other frequency areas? It might be stronger if we get it down to the hertz.
Yeah. But again, I think that's the problem with our world is we need to make technology that would allow all our appliances to work. You know, almost like a translation from one language to the other, an in-between transformation that would transform one kind of energy source to hertz, 200 or 110 where you are, volts. And it must also just be that there's a communication barrier.
There is, and I think that's that conversion that's going to become massively important when we fine-tune it on these devices.
Yeah.
That's going to get us there.
Because that would be easier to make something like that than to change all of the devices that we have, that we function on today. Unless they're all using static new devices. I mean,
Yeah, I don't think we're going to get there. Static kind of a really bad one to use. You know what I mean?
yeah.
That's just going to zap everybody, and we're never going to get ahead.
There's a few people I'd like to zap, but
oh man, yeah, this thing's really far down the list. Wow.
But that's okay. Imagine a structure. We have a geometrical structure. When that's formed, that then makes its own frequency because of the formation. So it's already sending out a signal without any power, just in its formation. That could be then it's to find the frequency of that and make our coils the same frequency that would then ignite, or they would be excited by the frequency of the geometrical structure already. It doesn't have to do anything. Maybe the pyramid's one of those.
Now we're talking geometry coil. That's exactly what we're looking for.
Yeah, that makes sense. And then there's no input because the input's already there by making the structure.
So, if you think about it, the structure internally of a crystal or a quartz is hexagon.
Yeah.
So if you make your coil as a hexagon shape, you're already starting to attenuate the same frequencies going in as they already have in there.
Yeah.
Now you just got to adjust it to where that particular crystal is.
That'd be very interesting if all crystals sing. If you like, if they're giving out this frequency, if everything sings, then it's just a matter of having Spotify play the right tune, isn't it?
Yeah, it really is.
Yeah, that's pretty cool to think about. Yeah, then we're already gone past what we need to do. We need to take the next step, as opposed to continuing with what we're doing now, because that was more like that's something that we should have been doing 200 years ago. Now we're trying to catch up, and where we should be now is maybe these geometrical forms and water crystals, and yeah.
Well, let me pull you into the woo a little bit on this one. So if you ever look at a mandala, you'll see a lot of different things on there, usually round. Yeah. And they'll have like squares in there, or they'll have triangles in there, or they'll have a certain pattern in there. Well, think of it this way. On the outside, they give you an indicator of exactly how many poles it needs. Then all you have to do is, if it's a circular one that goes like this in different layers, all you have to do is play keep away from the center.
Yeah.
And then when you do that, based on the outside, it creates a winding. Well, now put that winding into a structure that would match a crystal in some way, whether it be 5, 6, 7 sides, 8 sides, whatever that may be, right?
Yeah.
Now you can start to put this thing together that matches the frequency of the crystal, and they already have it written down in, you know what I mean, all these texts and stuff on all these mandalas of exactly what they were looking for. It's like the
face. Yeah,
right in your face. It's like, hello, we were here. We were trying to tell you something a while back, and you weren't listening. You know what I mean? Now you're going to listen, because now when you come across the same technology, you're going to realize we already had it.
Okay, this is strange. You've seen the old Superman films.
Uh-huh.
And his crystal technology.
Yes.
And that had a frequency or information or anything in it. I mean, what's not to say that would be the next battery if it was just put inside one of these resonating coils, just a frequency, that would be it. Because if it draws in from universal energy sources.
Mm-hmm.
That's weird. That's weird. Imagine that. That would be.
Oh, it's blowing your mind, isn't it?
Yeah, it's already blown. It's gone.
I always tell people there's a lot bigger rabbit hole we're jumping into than what you really think it is. And then it's why a lot of people have trouble getting to that next step of it is they're not seeing it. So I kind of dedicated my channel to bringing people on like yourself and others to show what they're seeing in these things. And you can't just do it, say, oh, we're all about motors or we're all about Tesla coils. It doesn't work that way. Energy in the earth works in all different ways. Like I said, 8 Center does organite, which is a whole different form of energy. And then, you know, we're doing this energy here, which closer relates to the energy we're used to seeing. But I'm going to tell you this right now. The energy in the earth is more like a radiant energy and capacitance than it is anything close to AC or DC.
Oh, yeah.
It's more like a crystal energy that runs our earth.
Yeah. Well, that makes sense because it's made up of that, isn't it, as well? It has to be that.
Yeah,
okay, so then you have cosmic energy filling up the capacitor. Boom. We're stood on a capacitor. And
well, if you think that the earth has layers, then this is why I'm doing my experiment, the next one I'm doing now, then capacitance and capacitance and capacitance in a layer is no different than a geometry coil building capacitance this way. We're just building it this way in the earth, right?
Yeah.
So we're sitting on basically a giant capacitor, and it doesn't take that much energy to start it. You just need a trigger. So the trigger, if the sun resonates and it matches something in the earth at the frequency of that particular, how do I say it, that crystal, then that resonates and already puts out the power. It's already putting out the power in the center of the earth, and then it builds capacitance in layers. So it's really interesting if you think about it in that way. It also changes your aspect of, why does the sun never turn off? Why do we never run out of energy? Well, because it's not built in the same way that you think it is. We're not running on carbon fuels. We're running on resonance. And because of that, until the center of the universe stops, it won't stop producing.
Or
it'll explode itself.
But then that's more energy.
Yeah.
And what does that become? Yeah.
Well, it's just put back into the system, I guess.
You know, a black hole, for example, there's a lot of theories around a black hole, but maybe that's the vortex in your coils, and the center is where the main in every vortex, the most power is at its smallest point, which is the center, which makes sense with you putting your rod down the center of your coils. If that is spinning from the top to the bottom or up, then it's drawing in the power into the center there. Yeah, definitely, that makes sense.
Yeah, we have like an in and an out, right? On a black hole, white hole. Yeah, one's an in, one's an out. They have different. It makes all the sense in the world. We're most likely repeating the same system over and over and over again, and we just don't realize it.
Yeah, I'm sure it's that. I mean, and if you say on some of these stones, was it in Ireland, where they have the symbols of the infinity circle, or what was it? Did you say the spirals?
Yes.
Maybe that's either side of a black hole. Who knows?
It was in Ireland. They have it on they have it on the rock.
Yeah.
So
we're just learning what they knew way back.
Yeah, and from what I understand, they layered their houses on, like, it's a big mound, right? They layered each layer with different things in there, and it was able to produce different frequencies and energies. And then inside the actual structure, it was like a resonance cavity.
Yeah.
So everything that we want, you know what I mean, for anything in the future, like the integrotron, right? It's a resonance cavity. That's what it was. You go in there, you know what I mean? 2 minutes in, 2 minutes, and then you're out, and it changes function that I can't go into medical, or else I would tell you exactly what it did. But yeah, it kind of changes, you know what I mean, how you function for the day. Let's put it that way.
Does it kind of reset everything? That's
Kind of like
interesting,
that,
isn't it? You know, I saw another program about the real structure of a church. When you go in, it's quiet, and you get a feeling of peace. But it's not because of anything other than the structure. The structure was made to act like as you said, with the mound builders. It's designed in that way to. It was used like a healing center, so people can just come in. Whatever was going on, they came out better, feeling better. Whether it's something mentally, it's so simple, so simple.
It's the same things with the crystals. People put them in their house so that they can feel better, so that the energy, they can feel like it runs through them, like when you're in a church and you're in a choir and you're singing, and then everybody in there feels that energy around you. And we think it's just, you know, our bodies thinking of it differently, but maybe it's a physical reaction in our body more than anything of picking up the resonance while you're in there.
Makes that just makes sense, doesn't it?
Yeah.
You know, all the frequency technologies that there are out there to make you better, to heal you in specific different ways. It's all about frequency, nothing more.
It's the future, and for that matter, it's the past.
Yeah.
It really is. It's to me, it's our lost history we're supposed to have. So something that we were supposed to have a long time ago, and then somewhere along the way, somebody decided it wasn't for us. And I think that started in the medieval times and stuff like that, maybe before that, when the church started hiding stuff from us.
Yeah.
And when that started happening, we were denied our future. So I think we're at a point now where we have to have it back. They've stopped technology for a reason, because they knew we were so close to that edge, and they're playing with a Pandora's box here, because you didn't let us learn it naturally.
Maybe that's it. Maybe we know it, but we don't know it. We've always known it. It's just if you say they can't actually stop it, they can stop it physically, but subconsciously we know it.
Yes.
And we've always known it. We just need to find a way of getting it out. That's the reason why I contacted that lady to give me a regression, because I thought, I know it. I just need to tell myself that I know what I'm supposed to be looking for.
Oh, yeah.
If you know what I mean.
I think we all remember it. It's funny. I talked to a lot of engineers. Basically, a lot of them are dyslexic. Like, they read things backwards. And I can't tell you why that is, okay? But I just have a theory about it. It's like one side of your brain works one way, one side of your brain works the other way, and there's two hemispheres in a vortex to each other, and one type of people just sees things the opposite way than the other. And I find that when people build things that way, like I get that way. I like to read it backwards. So if it was Greek, I'd probably do okay. We're just going backwards, right?
Yeah.
Well, I think a lot of engineers are that way. So to them, everything seems right, smooth, and easy as we build. And to a physicist, they look at it and everything seems opposite, right?
Yeah. Yeah.
Like
this cannot work.
It cannot work in nature.
Yeah.
But
it's only until we do these experiments and show that it can work, and the more of us that do that, and replicate and have the same observation, then we're a louder voice, and then maybe they have to listen, and then they would investigate and observe what we're observing. That's the only way I can see it going forward there.
Yeah, I think honestly we're probably what I know they suppressed in the 50s and from there on, but I think it's much older than that. Like I said, around Knight Templar time, they were suppressing it back then. I mean, for goodness sakes, the Knights Templar wrote it all over their church. The church had a certain frequency. On the outside, you start to see frequency patterns out there. I mean, just take somatics, put a speaker to water, right? Like a little tub of water above this, and put the speaker attached to the bottom. It looks different in water than it does in sand.
Yeah.
Or it does in salt. So you have to do both tests next to each other, and they're going to look different.
Okay.
They have two different patterns. Well, the mandala takes into account both those patterns.
Yeah.
So, yeah, I don't think people put that together. You have a geometrical pattern in your winding. You have one with the water, one with the sand. You start to put them into each other. Now the mandala starts to make sense. You're building layers.
So the sand, the crystal, the water, and the frequency from the that's has to be. And that would make sense with the earth, because the water stays pretty stable in the ground. The crystals are all around. The frequency is the next step. So I know we talk about the resonance of the earth, but even if we have that, that's not the right frequency just to be pumping in to get the same amount out. There's something else. Would that be, what would that be?
You got to start thinking of where that frequency is. Like, is it in the layer we're in? Or is it outside the layer we're in? Because they're basing the frequency patterns on what they observed from the earth coming out the top, right?
Yeah. What is it further down? Yeah.
What layer are we in?
Yeah.
Do we have solid mass around it? Because the frequency always is lower when you do. Do you have open air? So the frequency is going to be much higher. You see what I mean? So, think about it. In the layer that we live on, we're getting static electricity basically in our atmosphere, or close to it, however you want to say it. Okay?
Yeah.
It's basically what we're getting. So we know that the frequency that we're in is much higher the further up you go, right?
Yeah.
And then you have a layer below us where we're pulling the energy out, and every time we pull it out, it has more white in it. So we know that has more amps into it. So the frequency itself is much lower.
Yeah.
So now you start to put it together. What layer are we in? You see, I think the one thing that's missing in physics is they don't account for their environment as a functional math part in their whole thing. And if you did, then it would change the result of the whole project, right?
Yeah. That's the spooky part. Is it? Was it Maxwell left some bits out of his equation, or they were taken out of his equation to make everything else fit? If you Einstein even mentioned with Tesla's setups that he called it spooky at a distance. That was the technology. That's what he called it. He didn't. I mean, that's backward. He should have investigated it, and then we'd have been living under that.
Yeah.
But yeah, so there's the environmental impact on an energy system. That's what we need to be looking at, and the frequencies.
Let's look at Maxwell's equation. Everything's done based on a magnet.
Yeah.
But what part of the magnet are they missing? You see, that's the whole crux of it, isn't it? Physics bases everything on the magnet structure.
Yeah.
But what they're not basing it on is the part that defeats Lenz's law. See, they intentionally put that in there. Well, Lenz's law always states, Lenz's law always states. And then you get this thing about, fields and things like this and all the electrons and how they build up and then it causes clogging in your system, right?
Yeah.
What if I could tell you I could build it without the clogging, without a problem, by just simply running it without the heat in the system? Then you go, well, that's the other half of his equations that we missed. There's Maxwell's equations in reverse is what they didn't run.
Yeah.
And because of that, they don't have the other side of the picture of it.
Yeah.
And if they did, now we're saying, okay, what's the energy that defeats the Lenz's law? The radiant energy itself defeats Lenz's law every day of the week. The cold, when you get your negative to pull through the system and it goes a little colder, we don't have hysteresis, so you don't have heat. And if you don't have heat, you don't have clogging.
Yeah.
And that's as simple as it gets. So we're already understanding right now that, hey, number one, you left out half of it, and we're all feeling like, God, could you just get it right so that we can have the right equation at the end? But then they would have to go back and rewrite the other half of the law, and they don't want to do that. And if they know that they do, then over unity, all this free energy, or I wouldn't call it free, but environmental energy, they'd have to start taking into account.
Yeah, that makes sense. I've got all sorts of ideas now about making temperature experiments with some of these that we already do, just to see by cooling them if there'd just be a slight difference or a larger difference, which would make a lot of sense with what we're talking about there. It's
well, let me throw this one at you, okay?
Yeah.
And you're gonna do this because you're gonna see it the same way I guarantee it. Take that trigger circuit, put that frequency generator connected to that, and change the frequency of a DC flyback. That's okay. Just do the experiment. What you're gonna find is every time the frequency goes high, okay, then the static amount of the frequency is high. Every time the frequency goes low, well, then the amperage part of the energy is there, so you see more white in it.
Yeah.
Okay.
Yeah.
But when you get the more amperage part, it's hot. When you get to the static part, it's cold. So you're going to find a direct relationship in there when you start playing with it.
Yeah.
And then you're going to find out, hey, now hot and cold experiments are a lot easier.
Yeah.
Because now I understand the relationship between the frequency, and I understand what the heat does in the system, how the amps works versus the volts work. You know what I mean? And it builds a whole different system. I'm going to tell you, it's going to be like a aha moment for you. You're going to go, yeah, that old guy across the pond, man, he figured something out.
Yeah. Pling. That's cool. If you can send me the links of those, that would be brilliant.
Absolutely. I'll also send you the one where I can show the frequency and the everything like that going back and forth in the system, and it changes the amps and volts in the system.
Yeah, that would be excellent.
Oh, you're gonna love that one. So, yeah,
I'll send you the links to the 3D printed files for the Corona motor as well.
That motor, I'm going to pull it up for you, okay, on my channel.
Yeah.
I'll show you my big fireball. Give me a second. This one's a little easier. There's not millions of things to go through here. It literally, man, was a fireball. Yeah, I've done a ton of experiments with things, man. I forget half the high voltage experiments I've done.
Yeah, I often come back to doing the same experiment again that I should have made a video of and then categorized that and moved on. And then I've not. I've just left it on the bench and then gone on to something else and then come back thinking that I'm doing a whole new experiment again. And it's, oh no, I have done this again. I've done this before.
Yeah, you need like a checklist and
yeah, definitely.
A video number next to it. You know what I mean?
Don't do this again.
Yeah. Okay, here we go.
Oh, you have it.
Yeah. Okay. Oops. Sorry, there we go. All right, let me.
So originally I was going to build this thing as an atmosphere motor, and well, I failed. So I decided to just hit it with a lot of high voltage and see what it looked like. And well, you could see that it pretty much is starting on fire. Yeah, that was fun. All right. Anyway,
But it's still rotating, I can
have
see.
fun with it. And
Yeah.
towards the end, there's some
Well, because I have a drill at the back.
really cool. Anyway, if you like this kind of stuff, like and subscribe, but have fun with it. Thanks.
Yeah, you can see it in different stages. I don't think I followed all the proper rules or have the angle right or anything.
That's it. The problem is there's nothing specific online. You know, follow. Maybe I should put something out there where it's specifics of the angle and what I'm using and the breakdown. Maybe that will help.
Oh, it definitely helped me because this was a disaster.
Yeah. And it's irritating because you got so far and it's probably some small part of it that's been done differently. And then it can just all end in disaster, can't it?
Oh yeah, it's real fast. So yeah, that was a bad experience, man, because I had this whole idea worked out. You know what I mean? We'll just run it, you know, stage by stage by stage, and then we'll get a gearing structure in there so that we're able to change how it comes out, so it's usable, you know, energy right there, or usable power for a motor.
Well, that would have been ideal. That was the whole point. You know, we're using the atmosphere or the energy potential between the atmosphere and the earth to drive a wheel constantly. I mean, what can be more simple than that? That's as free as it can get, isn't it?
Yes, it is.
And that was what I found fascinating about it, and that's what stimulated my interest in it. It has to be simple so that everybody knows what we're talking about. The more complex it is, we lose the majority. Yeah.
Well, let's go a little further. Let's go into the woo a little bit.
Yeah.
If we took aluminum bismuth and aluminum and put it on the outside of a craft, and we got up to the atmosphere, and then we spun it, then we're going from static directly into the craft shell, which is the capacitor.
Yeah. It makes sense. That's why they look like they look majority, you know, the two discs, or if they're rotating internally or whatever it is, you know, that would be a perfect shape for it, wouldn't it?
Oh, it would. And think about it, because usually they say running up against a Mach wall, right? So we're pushing and we're trying to push it like this, right? Well, what happens if we're slicing and we're coming through it? Then we're changing the wall from being able to be in front of us, so it has to rotate around us. You know what I mean? Yeah. We're slicing right through. We're not. It makes all the sense in the world why you would do that step first.
You're not pushing. You're like diving into a tank of water. You know, you're going to have a smack, and it's going to hurt if you just jump in with a large area. The smaller the area, the easier it is to go through the water. Yeah.
So if we're talking like a razor thin blade, then it makes all the sense in the world why, I mean, you're just slicing and slicing and slicing.
Yeah.
And I mean, it's not maybe not the end all be all, solid state maybe, but it kind of gives you an idea. So now if you can take that into account, we're extending it to a field, and the field itself is rotating. Now it's the same concept. Instead of the physical, now to the outside of the field itself is rotating. Now we have no inertia problem. We don't hit that Mach wall. We've already went through it. We learned the secret.
With the everything that's spinning, for example, Corona motor, that's going to wear out because of bearings, rotation that way, physical rotation. The next step is a solid state. That is the only way. That's going to last a lot longer. It just makes sense.
Yeah, it makes all the sense in the world, doesn't it?
Yeah. I just need to show you.
Those are cool.
I was going to come on. I was going to come on like the mad scientist.
That's awesome. I love it. Oh, it's so cool.
There's some steampunk glasses or something. I thought, you guys have got to see that.
Oh yeah, that was awesome, man.
But what can we have a talk again, or what?
Absolutely.
Because of course now the time's ticking for me. Because I'll be at work while you guys are still enjoying Sunday. That would be great.
Yeah. I'll be honest with you, man. If you want to have a personal conversation, we could do that anytime. And if you want to come back on and do the show again, we can absolutely do that.
Yeah, I'm either. That's brilliant. It's nice to have made the connection. I feel there's a lot I can learn from you, and maybe you can learn something from my crazy schemes.
I think what it comes down to is bouncing off of each other. It's going to be the best thing, and I'm excited, man. That Corona motor it's been frustrating me. Like it's like one of those projects you haven't quite done yet, and you tried, you really tried, and I got to get back to it.
Could also be the I call it the lightning box, just for fun. I'll send you the details of how that's made up, what I've used there, because that may be also a big factor. There has to be something there, because these things don't always work on these boxes or other methods of generating the static charge needed. They don't always work, not on the larger examples. So I'll send that as well, Nathan.
I really do appreciate that. All right. Let me end the show real quick, man. I just want to say thank you for coming on. I really do appreciate it, Nick. This has been an awesome episode, man, and I hope everybody liked it.
Thanks, everybody. Thanks, Nathan. Take care.
I wanted to thank everybody for watching today. If you like this kind of content, we do a live show every Monday, Wednesday, and Friday right here on YouTube, 2 p.m. Pacific Standard Time on the main channel. The link will be in the description. Please join us, get in the chat, and have some fun. With all that said, hit the music.
The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.